Hey, what's up, everybody? Welcome back to my advanced programming concepts using C++. My name is Alex Luy. Now, what I want to talk about today is sending data into a function. So what you see in my little drawing here is where we have this black box, right, which I have over here. And when we're sending data to a function, we call them, there's many ways to define it. Now, I'm going to standardize it for our lectures. You may hear it differently talked about in different environments that you're in. I'm using the terminology that I've heard in a real life setting in my experience, and it doesn't mean that it's right. It's just the way that I've learned it and the way that I've come accustomed to using it. So let's look at some code before we go into the drawing part. Okay, here what I've done is I've written a little program that has one function. So this is my function prototype, as we've learned last lecture. And this function now has one parameter defined. And this parameter is going to be passed into the function. And once we pass it in the body, it's just going to print out the value, right? Now notice I said parameter when I talk about function definition. Now, how do we call the function? When we call the function, we don't call it how many parameters are you passing in. At least you can say that. I mean, it's mix and match. But what I usually say is, how many arguments does the function require? And in this particular case, it requires one argument. Now, one important concept here is that if you define a function with a certain data type, then whatever you call the function, whenever you call the function, the data type must be consistent. Meaning that I can't call this function with a string data type. You're just going to get either a compiler error or a runtime error. So make sure that you are consistent in terms of data types and then when you call the function itself. Now, before, you've already called functions in my previous lectures, right? We've used a POW function and other types of math functions where you've passed in arguments when you call them. But now you're writing your own function and you're defining the parameters yourself, and then you're going to use them to modularize your code. In this particular example, what I've done is I've defined a parameter called int. You can define any parameter you want as long as it makes sense to pass in to your function. This parameter, in terms of writing it in the prototype, you don't have to define it with the variable name. So what I've done here is I've just said int, and that's good enough. I'm going to show you in a little bit how we can create another function and write the function with multiple parameters. And then the call would require you to do multiple parameter calls, with multiple arguments, right? So in this case, again, if we step through the code, we're going to go into main. It's going to execute this passing 5 to the display value. We pass in the value 5, and then this value gets copied into our parameter variable called num. And then it's passed in, it executes the function itself. This is going to print out, and once it gets to the end of the compound statement, it comes back out, and then you print out now I'm back in main. So let's quickly run this real quick. And there you see. So passing 5 to display value, the value is 5. Now, I should say now I am back in main. Now I am back in main. Now let's draw this a little bit, because you know I love to draw, right? And let's look at a visual representation of what exactly is going on. So let's break this down a bit. So again, point of entry is main always, right? So this is our point of entry, right? So we can say that this is start. We've defined display value previous to main, so we have a prototype. So main knows that the name of the function, and it knows that it has a data type argument as an integer, right? Perfect. So this executes first, and then we come in here. So what's going on here? When you call the function displayValue, what's happening is this 5, so we'll just say something like that. So displayValue. This 5 is going to get copied and sent down to our actual function. So displayValue, right? When we do the function call, the 5 gets copied and then it gets substituted for num, right? So remember, the parameter that we used here is int num, right? So it's always got to be, when you do a function call, it's got to be a one-to-one mapping, okay? One-to-one. So what is this 5 mapping to? It's mapping to num, okay? So when we start execution over here, anywhere that the function references this variable, it's going to replace it with 5 because that's what we passed into the call. And now it's easy, right? So now we come in here, we're executing, so the value is, so what's the value of num? What do we pass in? We passed in the 5, right? So the value is 5, right? And then we end execution over here and we come back up to the line 2. I mean, the line where we were executing, which is displayValue. Go to the next line, this executes, and then you're done, right? One thing to always remember is that when you're writing a function and you're doing a call to that function, it's got to be a one-to-one mapping. I could not get away with just writing displayValue by itself on the function call, because displayValue has one argument that I need to pass in. And if it does that, it's going to be a compiler error. So we can, this is the, so argument is 5, right? And the number of arguments is going to be one argument, okay? So one important note is, so function calls, it's a one-to-one mapping. Okay, what that means again is that if you have one parameter that you've defined, the function call has to have one argument. If your function definition has 2 parameters that you've defined, then the function call has to have 2 arguments when you make the call. The other thing to realize is that right now we're starting out with function calls that are call by value, which means that it's going to make a copy of whatever it's passed in. And that's important. That's a little bit of an important concept to understand. I mean, I'm kind of sliding it in here just so you're aware, but we're going to get into more complex concepts when it comes to call by value and call by, or pass by value, passing arguments to a function by value, or passing arguments to a function by reference. Now let's take a look at another example where you can call this function multiple times. So again, in this particular example, I'm going to call the displayValue again. So if I run this program, you'll see that passing 5 to displayValue, the value is 5, then the value is 10, the value is 2, the value is 16, and now I'm back in main. Again, execution must start and stop with each function call. And that's why you get these messages here. So I hope that's easy to understand. Now I'm going to do one final example where we're going to find the sum of values. So showSum. We'll do integer, integer, integer. Okay, and then over here, we call it showSum because, sorry, it's going out of my, because we're just going to show it. We're not returning anything. I know you're very eager to learn how to return stuff from a function, but we're not going to get there. We're not there yet. Okay, we're going to get there. And what we're going to do is we're just going to say std cout num1 plus num2 plus num3 end line. So in this example, what I'm going to do is I'm defining a prototype, right? So I started with defining my prototype. My prototype has 3 parameters because I just want to find the sum of 3 numbers. Integer, right? Integer. When I call the function, it's got to be a one-to-one mapping, okay? You're going to see that in a little bit, okay? Now, defining the function, I'm going to define the parameter names, num1, num2, num3, and all I'm going to do is I'm just going to print out the sum. Okay, I'm getting far away from myself. I'm getting way ahead of myself. Okay, simple enough. So, how do we do this? How do we do the function call? Okay, remember that everything is a one-to-one mapping. So, I'm going to actually edit this program. The sum of 3 numbers and then I'm going to say showSum. So cool thing about Replit is it's going to write out the function call for you. So all I have to do is just type in the first few letters of my function name, and then once the IntelliSense starts working, I can just click on that, and then it's going to automatically give me the arguments that I need to pass in. So in this case, I'm just going to pass in 4, 5, and 6. You got to remember that when you make a function call, you do not pass an argument with a data type, right? It's got to be either a variable or it could be a literal, such as what we're doing here. So I'll show you variable in a little bit. So let's run this. Let's take this out for a spin real quick. So we run that. So the sum of 3 numbers is 15. So 4 plus 5 plus 6 is going to give you obviously 15. Now let us say that we don't want to pass in a literal. What I could do is I have to make sure that my one-to-one mapping does make sense, which means that if this is an integer, then what I have to pass in as an argument has to be an integer, which means that I can say int my num1 is equal to 5, int my num2 is equal to 6. Now I'm changing up the numbers, okay? My num3 is equal to 11. So now I can say my num1, my num2, and my num3. Perfect. Now I have variables that match the data types one-to-one, right? I'm not passing in any data types, right? Remember, on the function call, do not pass in data types. You just pass in either the literal or the variable. And then the function definition will do all the work for you, right? It's just going to take the variable and then just add them up and print it out to output. So let's run this again. And there you are. So the sum of 3 numbers, 22. And then control goes back to main in terms of function call. Now let's take a look at how this kind of lays out in a visual representation. You know I love to draw, so I can't repeat that enough. Okay, so here's a function call written out. Now, I want you to envision that when you make a function call, you're really drawing a black box. Let's draw a little box here. Okay. Inside this black box, you have a name. And here you're going to say that showSum, right? Now, the black box itself needs input, right? So what's an input? The input are the arguments that you're using to call it. And then the output is going to be whatever comes out. So sometimes you're going to have output that you're writing out using the cout object, or sometimes, which we're going to get to in later lectures, is returning a value from a function. And that's when it gets more fun, because obviously there's more concepts that you need to understand for that, right? So in this case, what we'll do is we're just going to draw an arrow here, and we'll just call this output. And it's arbitrary for now. We just know that for now our showSum uses cout, right? Eventually we won't get to that point. It's actually going to be something, a value that some other function can use, right? Now, in this particular case, we know that showSum is getting 3 inputs, right? So 1, 2, 3. That kind of reminds you of logic gate days, right? Where you have ABC or AB, right? So it's almost the same concept. It's almost the same concept, except obviously you're not using Boolean. The function itself is something that you've come up with, right? You've come up with that. So remember, one-to-one mapping. So this is num1, num2, num3. So what happens when you do a function call is it's got to be in order. So this goes over here, this thing goes over here, and this thing goes over here, which means that 3 gets assigned to num1, 4 gets assigned to num2, and then 5 gets assigned to num3, which means that anywhere that showSum is executing in terms of the body of the function, it's going to substitute those variables for the values that you passed in at the argument call when you do the function call. So as we take a closer look at the code, right, we've shown that when you define showSum, again, 3 arguments, so any values that are coming in got to be called in order, right? So when you call them in order, if we go back, this automatically gets mapped to that, then mapped to that, then mapped to that. Inside the body, those variables will be substituted by whatever was in the argument call. So it's kind of like a 2-step process. So the function itself won't know the actual hard-coded values until somebody calls that function, right? You're just defining and saying, hey, whenever somebody calls me, I'm going to substitute that variable with whatever value. So it makes it really dynamic, right? It makes it really dynamic. So let's circle back to what I originally said as to what happens when you do a function call and you pass it in. Well, when you're passing it in, you're passing in a copy. And I want to circle back to this because I want to kind of get your mind thinking about what's coming up next, right? What we call this is a pass by value. So whenever I pass in my num, it's going to make a copy of my variable in memory. And then when it makes a copy of that variable, it's going to assign it to num1. So if we take a look over here, let's take a look at a better example. So think about this way, right? So you have your function here, showSum, and then you have num1, num2, num3. When I called showSum in my main, and I used a variable called mynum, right? mynum1, mynum2, and mynum3. What I did, what's happening is, well, mynum is defined. What's the scope of mynum? The scope of mynum is actually in main, right? So it's only limited to main. So if I pass that in, what's going to happen is there's going to be a third party here that says, oh, because it's a pass by value, okay, by default, make a copy, okay, make a copy of mynum, and then assign it to num1. which means that if I were if something were to happen to num1 where I updated it with some other value, the scope of my num is again, it's to the main, but there is no changing of my num, because what happens, we made a copy of it, and the copy has no effect onto what happened to my num. So if I did a std cout somewhere over here in main of my num, its value would still keep the same because of this third intermediary step. When we step into a function call, which is a passive value, is before it even goes in and gets substituted, it actually makes a copy of it somewhere in memory. So we can call this kind of like a third intermediary step. So don't forget about that. That when you call a function and you pass it in a variable, it's actually going to make a copy first of your variable, then do the assignment to whatever you're putting in there. I hope that this was an enlightening experience on function calls and sending data. There's a lot more fun that we can do with function calls and data, and that's what I'm here for. That's what I'm here for. So I hope to see you on the next video. I know this was a little bit of a long one, but you can split it up. Don't have to do all 20 minutes, okay? I'll see you on the next video.